Hi, Pao. So let's start with 1A. It says, assume that the United States economy is in long run equilibrium with an expected inflation of 6% and unemployment rate of 5%. The nominal interest rate is 8%. A. Using a correctly labeled graph with both short run and long run Phillips curve and the relevant numbers from above show the current long run equilibrium. So, I'm so sorry. Um, Long run equilibrium. And so I draw the graph. We have inflation rate here, unemployment rate on the x-axis, and it says 6% for the uh, expected inflation. So we put it on this side. So sorry. I'm sorry. Okay, now the and we can see the 5%. The That is the unemployment, the natural unemployment rate. and we can see that it is at equilibrium and the lay point is labeled A. This is the long run and the short run piece. Then for B, it says calculate real interest rate in the long run equilibrium. So I use that formula gave us last class. It says nominal equals real plus inflation, and filled in the variables. We got 8 for nominal equals real, that is we're trying to find, 6, that is the inflation, and you just solve for one side and you get 2 because it is minus 6. Is 2% the real interest rate. And then the federal C. Assume now that the Federal Reserve decides to target an inflation rate of 3%. So this is gonna be taking money out of the economy, and this it says the Federal Reserve, not I'm sorry, it should say reserve, not government, should sell T-bills and bonds to the and take money out. What this will do was a increase a, increase the nominal interest rate, and since there is an increase in nominal interest rate, there is less investment, so um, there is um, there's a shift in demand, creating the lowering the the inflation rate, not inflation. Yes, the inflation rate. Then in D is using a correctly labeled graph of the money market show how the Federal Reserve's action should identified in Part C will affect the nominal interest rate. So as previously mentioned, we can see that there is a decrease in money supply, a shift to the left, and since it's a inverse, downward sloping curve, the money demand, there is an increase in the interest rate. For E, it says how will interest rate change you how will the interest rate you identify in part D affect aggregate demand in the short run? So since the nominal interest rate is higher, loans are more expensive. This means investment is lower, and this is since investment is one of the determinants um, for aggregate demand, it shifts to the left since there is a decrease. For F, for F1, it says assume the Federal Reserve actions is successful. What will happen to each of the following as the economy approaches a new long-run equilibrium? So for the first one is the short-run Phillips curve, and then explain. So the short-run Phillips curve will shift to the left because reducing inflation. Finally, for the natural rate of unemployment, it will stay unchanged because the things that are changing are not qualified as the determinants of the natural rate of unemployment. And the determinants are technology and innovation, quantity of resources, and quality of resources, and nothing of those have changed. Then going to question 2, it says assume that the reserve requirement is 20% and banks hold no excess reserve. So question A says assume Kim deposits $100 of cash from her pocket into her checking account. Calculate each of the following: the maximum dollar amount the commercial bank can initially lend. So they give you the required reserve, and you just multiply it times the full deposit. It's 100 times 0.2, that's 20%, and you get a 20. And that will be the part that will be given to the Federal Reserve. And then you subtract that 100 minus 20, the recurring reserve, and you get 80 to lend. And then for number 2, the maximum total change in demand deposits in the banking system. This question I had no idea, so I looked the formula for a change in demand deposits in the banking system, and it gave me this formula: 1 over required reserve times change in reserve. So I just plugged in, and yeah, 5 times 100, that is the change in the reserve, and this is the money multiplier, that will be 1 over 0.2, as we can see down here. That will be 5, so 5 times 100 will be 500. Finally, in number 3, the maximum change in money supply. This was just the simple formula: 1 over required reserve rate times the value you can lend. So it's $80, and you multiply it. So 80 times 5, and it's 400. And finally, assume that the federal bank buys 5 million in government bonds and open market operation. As a result, the open market purchases calculate the maximum increase in money supply in the banking system. So this one I had no idea as well, so I had to look for the formula, and it looks change in money supply equals change in reserve times money multiplier. So I found out that the change in reserve it's given, so it's 5 million, and the money multiplier we already got up here, and it's 5, so it's 5 times 5 equals 25 million. So that will be the change. Finally, for C, given the increase in money supply in part B, what happens to the real wages in the short run? And explain. So for this one, in the short run, wages will lose purchasing power because there is an increase in inflation. So we can see that this is the contrary effect of what we saw in this part. So instead of money supply shifting to the left, it will shift to the right, decreasing the nominal interest rate, and this will, since loans are cheaper, there is more investment, there is a shift in demand, and increasing inflation finally. Thank you, Pau.